we're still solving systems of linear equations. Right now we're still working on our third method of solution called the elimination method because we're trying to eliminate variables. We talked about yesterday that we can add or subtract these equations as long as they're in the same exact form, which they are. We have an x term, y term, the equal signs, and then constants. Alright, so when they're in the same form, we can add or subtract these equations. Now, if we add these equations, we would not get rid of the x's, and we wouldn't get rid of the y's either. So, we must have to subtract, right? If we subtract these equations, we're not going to get rid of the x's, and we're not going to get rid of the y's. So, yesterday it was always set up where we'd be able to add or subtract and get rid of one of the variables. Now we can't. But there's maybe something we can do to these equations. And that could be to multiply one of those equations by a number to alter the equation to be similar, but now be set up for us to use the elimination method. So if I look at the y's, can I get 5 to be 3? Not easily, right? Can I get 3 to be 5? Not that easily, right? It's possible, but it wouldn't be fun. Can I get 10 to be 2? Divided by 5, right? Can I get 2 to be 10? That's probably the easiest. We're looking for something that we can multiply to get to be the other number. So I'm going to take this 2x plus 5y equals negative 22, and I'm going to multiply the top equation by negative 5. Now let's think about this. I have 10x in the bottom equation. I want to have negative 10x in the top equation. Because then what operation can I use to get rid of the x? Addition. We talked about how that's easier. Could you multiply by positive 5? Sure, but then you'd have to subtract the two equations. It's possible. We're trying to make it as easy as possible for us. So I want this to be the opposite. So I'm going to multiply everything by negative 5. Because negative 5 times 2x is going to give me that negative 10x. When you multiply by negative 5, you have to do it to every single term in the equation. That means I also have to multiply it by 5y. So that's negative 25y. And I also have to multiply it to negative 22. That is positive 110. Please draw the line so you remember. You might even want to circle the negative 5 so you remember you're distributing that negative sign with it. It's a package deal. So the top equation is now changed to negative 10x minus 25y equals 110. The bottom equation stays as 10x plus 3y equals 22. And we said, what operation are we going to use to eliminate the variable? Addition, right? If we add these two equations, you're going to get rid of the x terms, right? Because negative 10x plus 10x is 0x, so it's just gone. Negative 25y plus 3y is negative 22y. And 110 plus 22 is 132. Okay? Any questions so far? Alright, let's solve for y now. We divide by negative 22. We divide by negative 22. And y is equal to 6. Good. Negative 6 is our y answer. Okay? So we know it's x comma y. We know that it's something comma negative 6. And if you weren't sure about that, you could just multiply 22 and 6. Check. 6 times 2 is 12. Carry the 1. 6 times 2 is 12 again, plus 1, 132. So it looks like we're in good shape. Okay. This is big. And this is similar to the substitution problems we were talking about earlier. We're now going to choose for part 2, right, one of the two equations. But we're going to choose one of the original equations. Excellent. We don't want to use this equation, okay? In case we made a mistake when we distributed the negative 5 to every term, we don't want to use that. Plus, those are also big numbers. So we definitely want to go back and use one of the two original equations before they were altered. So which equation should we use? Top or top? Okay, so we have 2x plus 5y equals negative 22. And again, we could have used this one, the 10x plus 3y equals 22 also for part 2. It doesn't matter which one of the two, as long as it's one of the original. So we have 2x plus 5. We're going to substitute in parentheses for y for negative 6. And that is equal to negative 22. And then we just solve our one variable equation. So we get 2x minus 30 equals negative 22. We're going to add 30 to each side. And we get 2x is equal to 8. We divide by 2 on each side. And x is equal to 4. So now, we know that our answer should be 4 comma negative 6 if everything worked out. All that's left is for us to do our check. Right? Because we use this equation for part 2, we have to use the second equation for part 3 for our check. So we're taking 10x plus 3y and setting it equal to 22. We're going to substitute our variables in. So we have 10 times 4 plus 3 times negative 6, and that is equal to 22. 10 times 4 is 40. 3 times negative 6 is negative 18. So 40 minus 18 is 22. And since 22 equals 22, it checks out. And we know that our answer